Welcome, and thank you for standing by. At this time, all participants are in a listen-only mode until the question and answer session of today's conference. At that time, you may press star one, unmute your phone, and record your name to ask a question. I would like to inform all parties that today's conference is being recorded. If you have any objections, you may disconnect at this time. Your conference host would be Mr. Steve at the top of the hour. Thank you.
In just a moment. Okay, good afternoon, everyone, from Kennedy Space Center in Florida. I'm Steve Seisloff from NASA's Office of Communications. Thank you for joining us for today's pre-launch news conference for the next SpaceX cargo resupply mission to the International Space Station. And this is for NASA's Commercial Resupply Services program. Liftoff of the uncrewed SpaceX Dragon spacecraft atop the company's Falcon 9 rocket will carry supplies, hardware, and science investigations to the International Space Station. It is currently targeted for launch on Thursday, March 21st at 4:55 p.m. Eastern Time. The rocket was just rolled up to the launch pad at Cape Canaveral Space Force Station, and we have several senior representatives with NASA and SpaceX with us today to talk about what this mission means. With us today are Kristi Duplichen, Deputy Manager, NASA's International Space Station Transportation Integration Office, Heidi Parris, Associate Program Scientist for NASA's International Space Station Program Research Office, and Sarah Walker, Director of the Dragon Mission Management for SpaceX. Our speakers will each provide opening remarks, and then we'll move to questions from reporters on the line. A reminder to reporters to enter the question queue, please use *1. And to start, we'll hear from Kristi Duplichen, Deputy Manager at NASA's International Space Station Transportation Integration Office.
Hi, thank you, Steve. Thanks, everybody, for tuning in. I'm very excited to be here, and I'm looking forward to the successful launch and arrival of SpaceX 30 to ISS. As Steve said, the launch will be Thursday afternoon with docking on Saturday. Our prime crew to monitor Dragon's arrival will be Matt Dominic and Mike Barrett. And Dragon will be docking to the Zenith port of Harmony and will spend about a month docked to station. SpaceX 30 is slated to deliver more than 6,000 pounds of cargo, research, and supplies. Some of that food that you may be interested in hearing about is a fresh food kit that contains some citrus, apples, cherry tomatoes. They have 2 coffee kits, which I think I would be probably the most excited about. The crew requested those, so we're making sure to get them some fresh coffee. And then they also have their standard menu items and some crew preference food. Our scientific investigations launching include studies of sea ice thickness, photosynthesis in space, and nanoparticle arrangements for quantum dot solar cells, but Heidi can share more on those. As far as the ISS hardware for the flight, we are launching a spare pump module for our external thermal loop in the Dragon trunk. ISS has been a very, very busy place. We're very excited to have our Crew 8 on board right now after the very successful handover from Crew 7 early last week. And we are preparing for a Soyuz launch on Thursday morning at 9:21 a.m. Eastern Time. And Soyuz will dock at 12:39 p.m. Eastern. The Soyuz crew will stay for about 6 months and return in September. And yes, you did hear me right. That is the morning of the SpaceX 30 launch. So we are very busy and excited to have an extra crew on board. And then in May, we are looking forward to the launch of the first crew Boeing test flight as well. So it is a very busy and exciting spring. I just want to take a second and recognize the hardworking folks that bring all of this together. It takes a lot of hard work, coordination, and partnership to get to this point. I'm impressed every day by the dedication and expertise that I see all of the teams demonstrate. So I want to thank those who support these missions and enable them to happen. So the ISS team and ISS is ready to support the launch of SpaceX 30. And with that, I'll hand it over to Heidi.
All right. Thank you, Kristi. Good afternoon. Thank you to everybody who has joined into this press conference today. We are very excited for the launch of SpaceX 30 and especially all of the fantastic new science that it will bring. The International Space Station offers an extremely unique environment to conduct research and to advance technologies in a way that we can't do anywhere on Earth. This state-of-the-art laboratory is supporting cutting-edge science around the clock from researchers all over the world in every major scientific discipline. And we're continuing to gather the key insights that can improve our lives on Earth, as well as helping us to explore further into space. So as Kristi mentioned, this year has been particularly busy for science on board the station. Just in the last few weeks, we've seen some really interesting research play out in real time, including testing out some techniques for performing robotic surgery in microgravity using a miniature remotely controlled surgical robot, and also the successful demonstration of the ability to manufacture Z-band optical fibers in space. So the SpaceX 30 cargo vehicle is packed full of the hardware and samples to support a very diverse set of new and continuing research from all across the international partnership. These investigations are taking full advantage of all of the things that the ISS has to offer, including exposure to the harsh environment of space, a unique vantage point in low Earth orbit, and also a prolonged access to that microgravity environment where researchers can quite literally take gravity out of the equation to understand their science at a more fundamental level. So I wanted to highlight just a few of the new experiments that are launching on SpaceX 30. First up, an investigation called nanoparticle haloing suspension. So this is using the microgravity environment to understand how charged particles of different sizes will interact and will arrange themselves in the presence of an electric field. So the end goal of this research is to apply the findings toward development of a new generation of more efficient solar cells through the use of something called quantum dots, which are tiny spheres of semiconductor material in order to efficiently convert sunlight into energy. Another payload called Advanced Plant Experiment 9, or APEX-09, is studying the fundamental metabolic behavior of plants, so studying how microgravity alters their ability to remove carbon dioxide from the atmosphere. This type of research could potentially help enable the development of bioregenerative life support systems. So these are life support systems that mimic the Earth's ecosystem by using plants to remove carbon dioxide from the atmosphere and generate oxygen. SpaceX 30 will also launch a CubeSat called NanoRacks Killick-1. This will be deployed from the ISS NanoRacks CubeSat deployer later this spring. And this investigation, which was developed by the Canadian Space Agency, will use a relatively new remote sensing method called GNSSR, which is Global Navigation Satellite System Reflectometry, in order to measure sea ice parameters from space. This monitoring system could contribute to a better understanding of important ocean phenomena, particularly in the North Atlantic region, as well as improve weather and climate models. And then the last one I wanted to highlight today is a technology demonstration called multi-resolution scanning, or MRS. It's going to test out new technology to support automated 3D mapping, sensing, and situational awareness functions. This technology was developed through a collaboration between Australia's National Science Agency and the Boeing Company. And it'll use our free-flying robots on ISS called the AstroBee robots to create a detailed 3D map of the interior of the ISS. And this team has big plans for future applications in spaceflight. You know, if it works well inside the ISS, this technology could be developed to use for scanning of exterior hull damage on the ISS or other space stations, as well as lunar and Martian surface scanning. So in addition to the 4 investigations that I just highlighted, SpaceX 30 is also going to launch research into many other areas, including cellular and microbiology, crystal growth, astrophysics, human research, material science, and much more. You can find information about all of the science launching on SpaceX 30 on our website, nasa.gov/ISS science. And before I hand over to Sarah, I just wanted to also talk a bit about some of the results that are coming from research on board the space station. You know, so we talked about research going up on this flight and some of the things that we are hoping or expecting to learn from that research. But until we actually launch the science, we do the research on ISS, we get the samples and the data back, and we do the post-flight analysis. We don't really know what we're going to find, and sometimes that's the beauty of science, right? You can end up with findings that are completely unexpected and can even lead to new fields of study. So every year, the ISS Research Integration Office tracks and releases a compilation of recent results that are published based on ISS research and findings. It's called the ISS Annual Highlighted Results. This year's edition was just published a couple of weeks ago. That can also be found on our website at nasa.gov/station results. And I encourage you to go take a look, check it out. Keep in mind that some of the research you heard about today may very well end up in that publication over the next few years. And it's always exciting to see what comes out of ISS research. With that, Sarah, I will hand it over to you.
Hey, everyone. It's great to be with you again so soon. I know I always say this, but it really has been a busy and exciting start to the year over here at SpaceX, and especially on our Dragon programs. Our last cargo resupply spacecraft flew to the International Space Station last November, and then it returned to Earth full of space science right before the holidays. Then a month later, in January, we had the exciting AX-3 mission and sent an all-European crew of commercial astronauts to the space station for 18 days. They conducted more than 50 research activities while they were on board the orbiting lab. Upon its return, we then launched Crew 8 to the station on March 3rd. It was a very clean uphill mission, and after about 27 hours, the crew docked with the space station to begin their long-duration mission. So they'll be up there for about 6 months now, where they'll conduct over 200 scientific and technology demonstrations. So a lot of the science that was just spoken about will be done by the Crew 8 crew. And then, of course, we completed the handover by bringing Crew 7 safely home last week. And here we are talking about the launch of the next shipment of fresh supplies to ISS on CRS-30. It really is amazing how much can happen over here in just a few months. I think what I'm most excited to talk about today is how we're launching a Dragon from Space Launch Complex 40 again. So you've all been asking a lot and seen the construction over there at Launch Complex 40 of the new crew tower. So CRS-30 will be our first Dragon to launch from Pad 40 since we put that brand new crew tower in place. Our last Dragon mission to launch from this pad was about 10 cargo missions ago and just a little over 4 years ago, 4 years this month, with CRS-20 on Friday, March 6th, 2020. So here we are at CRS-30, launching again from Pad 40, but with a pretty big upgrade over there on the pad. So CRS-20, that last mission to launch off of 40, was the last in a long and successful initial cargo resupply contract with NASA using our first iteration Dragon vehicle. And as you're probably aware, it laid the groundwork for a follow-on contract for another 15 cargo missions and counting. So I have personally worked on our NASA cargo and crew program since 2011, which was the year before we sent the very first Dragon vehicle to the ISS, which happened in early 2012. And I was a cargo specialist on many of the early CRS flights in the years that followed. So I was loading cargo into Dragon right here on Pad 40, and it was incredibly nostalgic for me to see the rocket and the spacecraft roll to the pad on those old stomping grounds early this morning. Back then, we loaded cargo while the vehicle was still horizontal using a mobile clean room before we would take the vehicle vertical for launch. But thanks to this new state-of-the-art crew tower required for our human spaceflight missions, that late load cargo operation got a massive upgrade too. It's much easier to load a huge complement of time-critical NASA science into our Dragon spacecraft in the flight orientation. So the Dragon we're flying today also has far greater capacity compared to the last time we launched a Dragon from Pad 40, which gives us greater opportunities for more science, technology, crucial cargo, and more to go to the station, while continuing to fly ISS hardware and unpressurized cargo in the trunk too. So Kristi mentioned that today's mission carries an ISS pump module in the trunk. This is a very large assembly that will serve as a spare available to this critical element of the ISS thermal control system. As I mentioned during the Crew 8 post-launch briefing a couple weeks ago, we recently completed all the tower qualifications and testing required and got all the approvals for Dragon human spaceflight missions on LC-40, Split 40. So we're really excited to be back at Pad 40 for this cargo mission. We're always thankful for opportunities like these to safely fly critical science supplies, fresh food, and snacks to the crew aboard the International Space Station. And I think I'll just conclude by saying thank you to NASA and the Space Station teams for your partnership, and to the 45th for all your continued support and weather insights. We're not quite close enough to launch to have a POV or probability of violation, but the weather has been trending pretty well as we've been watching it this week for our primary opportunity. So we're hopeful for a good day to launch on Thursday. With that, I think I'll hand it back to the moderator for questions.
Thank you, Sarah. A reminder to reporters to hit *1 to get into the queue, and if so we're going to go first to Jeff Faust at Space News.
Thanks. Question for Sarah. I'm curious, are there any upgrades to the crew access arm and other capabilities at Split 40 compared to LC-39A? For example, any lessons learned from your activities at 39A that you've applied to 40, or are they functionally identical? Thanks.
As Thanks, Jeff. Yeah, they're nearly functionally identical. There's a couple very small differences. The elevator got a pretty big upgrade at LC40 with some unique features, some extra fire safety ratings, and it's a bit more capable elevator. And then you probably remember that NASA used the 39A pad for shuttle missions previously. It's a very historic pad, and so it already had some what are called slide wire baskets, which is a secondary method of egress from the pad if there were an emergency on the pad where the closeout crew and the crew itself needed to get away quickly. And so we just use those NASA developed slide wire baskets, and then on 40 we use a very similar system for getting the crew away. It's like a chute that individuals can quickly egress from the top of the tower. So those are the main differences. Everything else is functionally identical.
Excellent. Thank you, Sarah. Quick note, Melody Lovin from the Launch Weather Officer at Cape Canaveral Space Force Station. She's from the 45th Weather Squadron. Can give us a quick look at the weather for Thursday's launch. Melody?
Hey, this is Melody. Can you hear me?
We have you, Melody. Thank you.
Excellent. Okay, so yes, I'm actually just about to release our forecast for our primary launch window. As many Floridians may realize, we actually have quite cool weather today. That's going to be changing as we get into Wednesday because the flow is going to turn back on shore. And on Thursday, we actually are going to have a low pressure system forming in the Gulf of Mexico, but luckily the launch window is just in the afternoon time frames, and it's probably going to be a little too early before that low pressure in the Gulf actually affects us. So the weather on Thursday afternoon looks great for launch. I'm going to give a 15% probability of violation, so that's essentially a 85% go for weather. And our primary concerns are going to be the thick cloud layers rule and the cumulus cloud rule. If we do need to utilize the backup window for Friday, unfortunately, the weather does deteriorate pretty significantly due to that Gulf flow moving through the Florida Peninsula during that time frame. So the POV for the backup launch window Friday afternoon is going to be 80%, which translates to a 20% go. And our primary concerns during that day are going to be anvil cloud rules, the liftoff winds, and the cumulus cloud rule. And we may actually have additional rule violations due to that. But hopefully we're able to make that initial launch window on Thursday because the weather looks great for that. So with that, I'll go ahead and pass it back to the moderator.
Thank you, Melody. Very good news. That all sounds very good. Next, we're going to go to Will Robinson-Smith at spaceflightnow.com.
Hey, Steve. Thanks for passing the mic to me. And question for Sarah. You and your colleagues at SpaceX have mentioned using some of the non-crewed missions to look at potential upgrades and ways to push the capabilities on Falcon 9 and Dragon, and I wonder if there's any that are going to be showcased either with the launch, docking, or landing of this Dragon that's flying CRS-30. Thanks.
Hey, nothing particularly unique on this cargo mission. Sorry, I not have more exciting news.
Thank you, Sarah. Next, we're going to go to Jim Siegel at nasatech.net.
Hi, everybody, and thanks for taking my question. It's either for Sarah or Heidi, I believe. I'm interested in what are some of the specific time-sensitive cargo that are going to be on CRS-30, and when will they be loaded? And what happens if the Thursday launch has to be rescheduled? How quickly do they need to be replaced by something else? Thank you.
Hey, I think the exciting answer to this question is all Heidi, but I can speak quickly to your operational piece of the question. So we start loading the cargo about 24 hours before launch. So tomorrow afternoon, evening, we'll load those powered payloads and cold payloads things that need refrigeration, things of that nature that you want to load at the last minute. And then we work together with the cargo teams over at NASA to look at the duration of transit for each launch opportunity. And then we calculate, we usually are able to get a couple opportunities on the same load of science samples. So they're adding in the time between the 24 hours before and the launch itself, and then the transit time, and then the transit time for a backup opportunity. And it's different every time. It just depends on what unique science is on board. But usually we get a handful of opportunities before we would have to go back over to the vehicle and maybe swap out some things. So Heidi, I'll let you speak to what's on board this trip.
Yeah, thanks, Sarah. Yeah, so I think a lot of the samples that tend to be late load are related to the biology area, so cellular biology, microbiology, things that have sample lifetime limitations that we can't necessarily load ahead of time because those cells will not be viable by the time they get up to the space station. So, I mean, some of the types of things that we have on this flight that would fit in that category, we have research into bacterial population survival on board the space station. We have research into neurodegenerative disorders. We have a number of crystal growth investigations that are looking into different disease models and understanding and identifying the types of proteins that are responsible for the spread of diseases so that we can create better and more efficient modules to slow those down. We have some investigations looking into the nervous and vestibular systems. So those are the types of science investigations that tend to be loaded later in the flight on these vehicles.
Thank you both. Did have a we're going to stick with Heidi here for a minute. Have this question for Heidi. How could the multi-resolution scanner payloads 3D mapping capabilities on Space Station prepare NASA for future exploration missions?
Oh yeah, that's a great question. So I think there's kind of a couple of things that are key with this type of technology that's being tested out, right? So the first one is that the technology used is going to use dissimilar sensors to create a better product in a way that you can't get with just one type of sensor alone, right? So it integrates active sensors that generally provide very quick, very basic information with passive optical sensors that give you a lot more precision and a lot higher density, but they tend to get bogged down with slower processing if you're using them on their own. So by integrating these different types of sensors, the result that we get is a software and a hardware system that can achieve higher fidelity 3D images much quicker and in a much more effective way. And the other thing I'll note, this payload is, it's very small, but it packs a lot into a small package. And that's really important for space exploration, right, where everything needs to be smaller and lighter and more portable, more efficient, because those are usually the things that limit us for space flight systems. So that's a common theme, I think, throughout space flight technology. We take the things that may be huge and heavy on Earth, and we figure out a way to make them just as powerful, sometimes more powerful, but in a much smaller package. So I think this has, potential applications for autonomous inspection of structures and on, future space stations, but also in places like the Moon or Mars. And it's also interesting, a lot of the technologies that are developed for spaceflight also have applications in remote areas and disaster situations, because those are also the type of places that need small, lightweight, portable technologies. And this one was actually developed for mining and manufacturing applications originally, because those are some of the same type of conditions that we have in remote locations in space.
Thank you, Heidi. Up next, we have Irene Klotz from Aviation Week. Go ahead, Irene.
Thanks very much. This is for Sarah. At the Satellite 24 show this morning, Gwen talked a little bit about the sale of laser comms terminals, and that one will be tested on the Polaris mission this summer. Are there any ideas about incorporating that on your cargo and crew Dragons for NASA, or any upgrades to allow the sort of reentry views via Starlink with the terminals that were connected on the Starship demo last week. Thanks.
Yes, I think we're hopeful to offer that capability on future missions. Obviously, nothing on board this mission, but yes, I'd be hopeful that could be a great capability to offer NASA in the future.
Thank you. And we have our last question today coming from Ken Kramer, Space Up Close. Go ahead, Ken.
Hey, thank you for doing this, and good luck on Thursday. Two questions, if I might, since I'm the last one. I would like to ask Heidi, can you tell us some more details about the progress with this robotic surgery experiment and how that's important for the future? And for Sarah, can you tell us, if I understood you right, you said all the testing was done to enable a crew launch from Pad 40. So I'm wondering when might that be? What might it be? Crew 9, Axiom 4, Polaris Dawn? What is your thinking? Thank you.
All right, this is Heidi. I can take the first one. Talking about the robotic surgery demo. This is a really great, I think, really important first step toward eventual development of remote surgical capabilities. So in this case, right, we were using a miniature remotely controlled surgical robot on the ISS. It was being controlled by a team, I believe, at University of Nebraska. And they were not operating on, tissues, but they were using a system of rubber bands that was indicative of, what the tactile response would be from those type of systems. And basically, they were looking to see whether the data latency, between the ground operator, performing the operation and what we saw in flight in terms of that time of response was going to be acceptable. And I think the initial indications were positive, but of course we need to take a look at the data and understand exactly what was seen. But I think it's really exciting. This is the first step that can be used in the future to develop those capabilities that may be necessary for long-duration space exploration, where you may not have, a doctor with the right type of medical expertise to operate in a remote location.
And to answer your question about Pad 40, so I think it's important to remember that historically Pad 40 has kind of become our high-rate pad. We've gotten the time between launches down to just a couple days. It's really incredible, and so it's really optimized in all of our operations for that high-rate, like satellite launch arena. And then 39A historically has been our Falcon Heavy capable pad, our Dragon capable pad, our uniquely complex missions fly at a lower rate over on 39A. And so it's hard to predict what the manifest will call for going forward, but we are kind of done on the SpaceX side with all of the qualification testing and simulations. And we have a unique partnership with NASA on Commercial Crew Program, where they have approval authority and jurisdiction over everything that touches the NASA astronauts, including all of our ground systems. And so there's a pretty hefty amount of what we call verification events, certification work that we submit to NASA Commercial Crew Program ahead of the NASA CCP launches, and that is kind of well underway with completing that certification effort with NASA, and I think they're on track to be pencils down on that for NASA crew missions ahead of Crew 9. But again, we'll move over to LC-40 when we need to for the manifest, and I'm really glad we got to be back for this one. But we also have 39A, and so when we get closer to launches is when we make the decision on what's best for the manifest and the customers.
Thank you.
Thank you, Sarah. And thank you again to all of our panelists for taking the time out today for this as we head into this CRS-30 mission. NASA TV coverage of the launch will begin Thursday, March 21st at 4:35 Eastern Time. That's the coverage start. The liftoff is scheduled for 4:55 p.m. Eastern Time. And you can stay tuned to nasa.gov for launch updates. I hope you enjoy the rest of your day. Thank you, everyone.
That concludes today's call.